Okay, guys, so today let's work on another coding question that can be asked during Facebook interviews, which is the 339 nested list with sum. All right, so for this question, you're going to be given a nested list of integers, which is called nested list, and every element is either an integer or a list, and whose elements can be also integers or lists. So the total sum of this nested list is like for every item multiplied by its level of depth, and then we can just sum all of them. So for example, let's look at this first example. So the first item is the value is 1, right? But the level of the depth of the integer is 2 because it's inside a list of the parent list. So it's like first list, second list. So the level is 2. And same for this item here. The level is 2 and the value is 1. And for this item, the value is 2, but the level of depth is 1 because it's just inside the parent list. And the same for these two, their values are 1, but their level of depth is 2. So for this problem, we can use recursive function to solve this. So usually, when we can use a recursive algorithm, so usually when the child problem is very similar to the parent problem, then we can solve these problems recursively. So in this case, like the input is a nested list, and every item inside of the input can also be a nested list. So in this case, like when we are solving every element, every item inside of the input list, this child problem, which is can also be a nested list. So it's exactly the same as a parent problem. So when we are solving the child problem, we are also solving a nested list. So in this case, we can do this recursively. All right, and here we have all these interfaces defined for the nested integer. So this nested integer is what we have, is every item we have inside the list. And it has the following interfaces, like we can say is integer or not, so which will return true or false when this item is an integer, and they return false when the item is a list. And this add will add an integer into the list. Let me scroll down a bit. And this set integer will is like this nested integer is to hold a single integer. Okay, so this is just to have the item to hold a single integer. And the get integer is to get the value. If it's a single integer, then we just get the value of the item. And the get list, if it's a list instead of an integer, then we get the list of the item. All right, so let's just start solving that. So usually for recursive functions, for recursive algorithms, we need to define a helper function, which is just we're gonna call it recursively. Helper function we're gonna call recursively to solve the problem. So what's the input parameters we're gonna put inside of the helper function? So the input first will be, I think, of course, will be the child list, which is a child problem we're gonna solve. And also we're gonna need to keep track of the current depth of the child list, because every item in the child list is gonna be multiplied by the depth, by the level of depth, right, of the child list. So that's why we need to keep track of the depth, and then like we just need to return. So when we get a helper function, like for the total sum of the nested list, we can just call the helper function on the input list with a depth of 1, because the initial depth on the input list and the initial depth will be 1, right? Because every item in the input list will have a depth of 1. And we can just, and we can just return the output. All right, now let's sort out the helper function. So for the helper function, like we're gonna need to calculate the sum of the child list, the total sum of the child list. So let's say child sum. So that's initially will be 0, right? And then for every item inside the child list, if the item is an integer, is integer, then we can just add it to the child sum multiplied by the level of depth, the item dot get value, get integer, and then multiply it by the depth. Otherwise, it will be So if it's not an integer, then we know like this, it will be another list inside the child list. So we're gonna solve the list inside the child list. So the nested list inside the child list. So the nested child sum would be, we're just gonna call the helper function again on the nested list, this item, and the get list. Yeah, we're gonna get the list. And the depth of the new list, new nested child list will be incremented by 1. This will be the new depth. And also, then when we get a sum, we just add it to the child sum, right? And then we can just return the child sum. All right. So let's run it and see how it goes. Okay, yeah, it's good. So this is the solution we're gonna have for this problem. And then for the time complexity wise, we are, so let's say like there are in total n items inside of the n integers in total inside of the input list. So the time complexity will be order of n because we're gonna add up add up all the every single item multiplied by its depth, level of depth. So the time complexity will be order of n. N is the number of integers. So n is not the number of items in the nested list, is a number of total integers. So for example, if the nested list only have 2 items and each item has 4 integers, then the total time complexity will be 2 times 4. It will be total time complexity will be order of 8. So it's the number of integers inside of the total number of integers in the lists in total. That's the n. So the time complexity will be order of n, and the space complexity will also be order of n because we are stacking the recursive calls, right? So it will be saved in the stack. So that will be also order of n, space complexity. All right. So this is the this is all for this question, and I'm gonna see you guys in the next question.